Alright, so our CAD project was to act as the lead designer for a rover for NASA at JPL. You can go a number of ways with this project, but of course there are some constraints. The rover must not exceed 3 meters long, 2.7 meters wide, and 2.2 meters tall. It also must require certain parts to be present in the assembly. Articulating arms and claws, a massing camera, chassis, suspension, wheels, RTG, solar panel, and any extra parts we found necessary or looked cool. And these parts should be made to function with each other. That's pretty much a given. Now on to how I came up with the design. Originally, I was going to make a really complex, cool looking rover design that would take ages just to completely model, kind of like this one right here. But after many failed attempts, it just wasn't looking right, and I realized I wasn't prepared to make another complex model. I decided it would be really nice if I was able to make it completely cubed, just extremely simple over overly complex. As I was thinking about ways to cover over the fact it is just a cube, I thought of the first thing that came to my mind, Minecraft, and there we have it. I designed a Minecraft sheet for my Mars rover. Creating this design and modeling was extremely easy as it is all cubes. I just found a random picture on the internet and copied it. The chassis has 4 holes, 2 on either side, 2 armholes, 1 for claw and 1 for drill, a small hole on top of the chassis for the solar panel, and a giant hole for the collection system. All their parts generally attached directly into the chassis, like the camera or the RTG. And now for the descriptions. So the chassis holds all the parts. It's basically the main frame. The camera and camera mast used to record or take pictures of the surroundings. The solar panels are used for extra energy, the extraction of sunlight. The main arm axle on the arm holds the claw and drill pieces. It's the main part of the arm. Use it for both. The claw piece and the claw itself used to grab the sample tubes and place them accordingly into their sample holder. The drill piece and drill bit, they used to drill out material out of the Martian soil to be collected. Now the sample holder is just a big circle that holds all the sample tubes, and the sample tubes holds all the material for the scientists to collect. Now the RTG, it's basically the main energy source for the rover. It converts our heat to energy with radioisotopes, kind of with uranium, usually, I think. Suspension allows the wheels to traverse over rough lands and actually provides some shock protection. And finally, the wheels are used for movement. Now for our, the motion studies and how they work. The wheels move accordingly along the suspension, just to move the rover. It's usually not this fast, it's actually pretty slow. Suspension moves the wheels up and down. The camera spins around for a full view of the landscape, and the spin is pretty awesome. Sample system also spins for the claw to reach the actual thing, like every hole. And the claws and drills are able to fully articulate to go under the rover and all that stuff. Now, how the articulation on the drills and arms work. So it's very simple. It just uses pegs. It's connected through holes. There's like little through holes. Connects with pegs. It's very, very simple. Gets the job done though. Works like a charm. And the solar panels and the RTG move because I don't know, it's funny. And now the full size of the rover is 104.528 inches long, or 2.66 meters. 65.831 inches wide, or 1.67 meters, and 68.291 inches tall, or 1.73 meters. And that's it. So yeah, cool.
Showtime!